Okay. Okay, so quad this is week 83 of the Perl Weekly Challenge. Got another video which is showing me doing all of the solving and stuff in Dialog APL. And for this part, I'm literally just going to be going over my solutions and talking about some of the caveats in a bit more of a concise manner. So let's do that. So for words length, I ended up with 3 different approaches, all with different advantages and disadvantages, basically. So my approach to the challenge was to start with my intuition, which was to basically just separate my string, my word character array, into a nested array of all the words, at which point I can drop the first and last word, get rid of that nested structure, and just count the number of elements. So that's the basic approach, and that's short and sweet, and works quite well when we have no punctuation. What I've ended up with in my first version is the same principle, but we're generalizing. So I've got some lorem ipsum string and made it a bit longer. So that's 9,999 characters. And it also contains full stops and commas. So I've generalized the expression to split on not just spaces, but also full stops and commas. But you can obviously extend this for whatever your corpus is. But then it's basically the same idea. In the second version, I decided, well, creating a vector of nested vectors. For each one of these boxes, we have a pointer to another array in memory. And for a long string, that's going to get really inefficient, allocating all of those separate arrays, only to get rid of the structure at the end to count the number of characters without punctuation. So this version is my quick stab at a flat array version, where so we're not producing a bunch of intermediate nested arrays, and we're sort of computing the position of the space after the first word, and the space before the last word, and using that to chop the first and last word off. So let's have a look. So I've also gone for binding comma space full stop to alpha, and then we've got omega here, and it's ellipsum. It's ones where we have commas, full stops, and spaces. Then this stuff is basically just being fancy to let me do it all in one go, right? So it's my Boolean vector laminated with its reverse, and this is just because I know a quick little idiomatic way to get the first one in a Boolean vector is pick a top where. So I can do pick a top where rank 1, which means on each row on my 2 rows here. So pick a top where rank 1. And this tells me that the first one in the first row is at position 6, and the first one in the second row is at position 3. And this just tells me how many characters I need to drop from each end. So we can probably get that far from my original text. So we're dropping 6 characters from the front and 3 characters from the end. 6 characters from the front minus 3 characters is 3 characters from the end. And then we just remove all of the elements in alpha, get rid of all of our spaces and punctuation, and count the number of characters. And so for short, I'll show you runtime in a second, but for short for short strings, this is a fair amount slower because it's doing a lot more computation generally, but for longer strings it's much faster because having to allocate all those arrays in my nested array for the other version ends up being slower for the longer version. Oh, actually I have the runtime up here. So actually, while I have that up here, let's just talk about the third one. So the third one is pure regex. Except in APL, you can give multiple regexes, and it will sort of do them all at once with the precedence of generally being consumed by the first hit. But in this case, that doesn't really matter. Well, I guess it maybe technically does. If we'd done the remove non-word characters first, maybe this would break. You can test that yourself. I'm not going to do it now. My idea is, in regex, get rid of the first word, get rid of the last word, get rid of all non-word characters, count the number of characters that remain. And, because regex is sort of designed for this type of processing, it's quite succinct and versatile, but the PCRE regex engine is slow. So Lipsum is this 10,000 character almost vector. For the two samples, the first approach was actually the fastest, especially if you do with the space not equals here rather than the generalized version. The first one's fastest on short arguments. The second one ends up being about a bunch faster. It's a factor of 10 on a large argument. And PCRE is it's very versatile, but it's just a bit slow. I mean, you got things like, for example, I've manually put in, there are assumptions about the data in my APL solutions, whereas with regex, non-word character is defined within regex. I don't have to care whether, if I had question marks in there, I'd have to add question marks to my solution. Or basically when I submit my solution, in the real world, I have to think ahead, just list all of the punctuation marks. Maybe I'll do that before I upload. But anyway, that's words length. Right. We'll just chop off the first and last words, take out all of the punctuation and spaces, count the number of characters. Okay, so the next one was flip array. This one, basically, I went with my gut instinct. It seemed to go all right. I stuck with it. So the idea is that you have some numbers in a list, okay, and you can flip the sign of any of them, like 0 or more of them. You can flip the sign, and when you do that, so for example, if I do neg1, 1, 1 times omega, I can flip the sign of 0 to 3 of them. So actually that's from omega to minus omega. Then when you sum them, you'll get sum. So negative 21 or positive 21, or presumably some number in between negative 21 and positive 21. And you're trying to find the flip sequence which results in the smallest non-negative number. Right, so 0 is, the best case scenario. If you can't sum to 0, then just get as close to 0 as possible. But it has to be positive. So I decided, since it's generally a smallish search space, so that's one thing that you could definitely improve on from my solution. I've gone for the breadth first search. My old classic, my old friend, give me all the powers of 2 up to a certain length trick. So what's that? 3, 10, 8, which for length 3 is not too bad. Then doing some arithmetic to make them negative 1s and 1s rather than 0s and 1s, since that's what we're after here, some combination of flips. From flip them all to flip none of them and everything in between. Yep. Then we... I need to fix my solution a little. Yep. Okay. So we then transpose the flips, right? So that we can apply this type of multiplication row-wise using rank 1. We sum them up since we only actually care about the sums. Filter out positives, or rather filter out the negatives and keep only the non-negatives. Find the index of the lowest one, get the flip which corresponds to that. So let's demonstrate that with, I think I've said enough on thinking in the method. Let's just go for an example. So as I said, here are all those possible flips. Here's the input with those sign flips. Then there's all of the sums. There's all of the positive ones. Okay. Which is the min flip? It's 1, neg 1, 1. Just as they said here, that flipping the middle one gives you the result of 1. That corresponds to this third from the end flip. And then the actual output it's asking for is just the number of flips. And in our representation, that's the number of negative ones in this array. And that's the whole problem. So that's been week 83 of the Perl Weekly Challenge in Dialog APL. Thanks very much for watching. See you on the next one. Okay, bye.